हाँ इसको पकड़ लो। हैं? ये आपसे यहाँ पर।
पापा ये देखो ये क्या कर रहा है।
Hello, dear Tivisha. Welcome to class.
हेलो सर।
So let's get started with our class. As we have finished some of the topic in the previous class related to the water. So the question of the remaining topic of the water, which the water solvent, solute solvent, solution, and the polarity of water molecule and as its universal solubility. So here is your first question. Which of the following is a solute in the sugar solution? Sugar, water, air, and salt.
शुगर।
Okay, you are absolutely correct. Let's move on to the question number second. Which component is the solvent in the salt water?
वाटर।
You are absolutely correct. Third question. Which of the following is a solution? Air, oil in water, sand in water, sugar in water.
शुगर इन वाटर।
You are correct. Moving on to the four. Water is a polar molecule because it has equal sharing of electrons. It has bend shape and unequal charge distribution, and it is a non-metallic. It forms ion easily.
It has equal sharing of electrons.
You okay? The question was, water is a polar molecule. It has equal sharing of electron. It has a bend shape and unequal charge distribution. So I think option B would be the correct answer in this question. It has a bend shape and an unequal distribution. What is equal sharing of electron? So why it is not water molecule does not shares equal electrons when it comes off oxygen. So oxygen shares 2 electron while the hydrogens are sharing 1 electron each. Although two hydrogen, but they are separate hydrogen. They are sharing only 1 electron, and oxygen is sharing 2 electrons. So that is why the sharing of the electron is not equal. And also electronegativity is the thing that actually makes the compound polar, because the oxygen is more powerful or hydrogen are poor fellow we can consider. So element with the higher atomic number are generally we can consider more powerful electronegative. Although three element like uh, uh, oxygen, nitrogen, and fluorine. These are the most electronegative element of the periodic table. But as a general rule, you can consider the atomic number greater the atomic number, greater will be the electronegativity force for a simple definition. So option B was correct. Nonetheless, moving on to the next one. Which compound is ionic? NaCl, CO2, CH4, and H2O.
NaCl.
Okay, you are absolutely correct. And let's move on to the question number next. Why NaCl is a correct answer?
I want to explain also.
Okay,
Because Na is positive, Na which means salt. No, sorry, which means I. क्या था उधर? Na
iron.
is so yes, sodium. Yes, sodium is positive, and chloride, which is Cl, is negative. So the mixture of positive and negative makes an ionic element.
Okay, you are absolutely correct. And we have understood why H2 is a polar covalent compound in the yesterday class because of the sharing of the electron, mutual sharing of the electron. It is not equal but mutual, meaning hydrogen gives and the oxygen gives too. CH4 is also a covalent compound and CO2 is also a covalent compound. Only the NaCl is an ionic based compound. So first Na, which is sodium, has to be positive. So it loses its electron and it becomes positive. And the Cl, which accept the electron, becomes negative. Now these elements combine with their charges. We call them ion. And hence the ionic compound. Let's move on to the next question, sixth, which says which compound is covalent, NaCl, H2O, KBr, and MgO.
H2O.
H2O is absolutely correct answer. We have studied in the previous class. Hydrogen shares one electron with the oxygen. That's why mutual sharing of electron, they form a covalent bond. NaCl we have discussed just a moment earlier is a ionic compound. KBr is also ionic compound and hence MgO2 is a ionic compound. Moving on to the question number 7th. Water is called a universal solvent because it can easily dissolve all the substances. It is cheap, it evaporates easily, and it is a polar. Why it is a universal solvent? The question is asking.
So it can dissolve all substances and it is polar. Both can be the answer because
Okay. When it comes to the water, it is polar.
yes,
Uh,
sir.
it is polar come covalent bond, a covalent compound, polar come covalent compound. So the question was why it is universal solvent. If the question option D is polar come covalent compound, a polar covalent compound, that we might consider it a answer, but we can now here consider A as a solo option for this particular question because it can dissolve all substances. Because question was asking about the universal solvent of the property, not on the water compound, which kind of the compound is it. I hope things are clear to you now. Let's move on to the question
Yes, sir.
number 8. Which of the following is
But
not a
sir, so in the
yes,
answer it was written it is polar.
the answer was polar. Okay, its polarity allows to dissolve many ionic and polar compound. Water is a universal solvent because it can dissolve all substances. Actually, yes, the option fourth need to be the answer. It cannot dissolve all the substances. Uh, Oil is an exception for that. I beg apology. Let's move on to the question number 8. Which of the following is not a soluble in water, salt, sugar, oil, and ethanol?
Oil.
You are absolutely correct. Let's move on to the question number 9th. And can you give reason for that oil is not a soluble in water?
So because oil is neither an ionic nor an covalent substance. And so I just wanted to ask what is the meaning of ethanol?
Ethanol. Okay, so the answer of the first, oil is not soluble in water because it is a purely covalent substance. It will not dissolvable in the water because water is polar cum covalent compound. That is the reason. Also, there are some other phenomenon related to the dissolvability of some substances. You will be understanding them in the later classes. When it comes to the chemistry, I can say no law is absolute. Some every law, almost every law has exception. Now the ethanol. So ethanol is a part of alcohol. So a group of alcohol homologous of the series alcohol. So there are other compound ethanol, methanol, ethanol, propanol, butanol, pentanol, hexanol, or octanol in the ethanol category. So ethanol is used widely in the liquor, which have been used, which is being used as a intoxicating substance in India or in the entire world. So it is a main constituent of the liquor, ethanol, while some of its other compound like methanol can also be used in the industrial purposes. Is it clear?
Yes, sir.
Ethanol is the main constituent of liquor.
Liquor.
Okay. Have you ever tasted ethanol?
No, sir.
Okay. If you ever have tasted cup syrup or some kind of the medicine, it also contains
Yes, sir.
ethanol.
It contains alcohol or ethanol.
During Corona time, there was a saying that use ethanol based alcohol because it kills many of the bacteria and some of the viruses too. Question number 9
Okay.
says in a sugar solution, if sugar amount is increased, the solute will be decreased, increased, or same or zero.
Increased.
You are absolutely correct, and it was easy question. Question number 10 says in a solution, the substance present in larger quantities, usually solid, solvent, solute, both equal and cannot shake.
Solvent.
You are absolutely correct. We have understood two of the identity of a solute solvent. How do we identify them? Wider connotation. In a wider connotation, we can understand by their amount. Larger is solvent, lesser is solute, and then we can dive a little deeper. Question number 11th. Which of the following is a solute in a sugar solution? Sugar, water, air, and salt.
Sugar.
You are absolutely correct. Let's move on to the question number 12. Which component is the solvent in salt water? Salt, water, sugar, and oil.
Water.
You are absolutely correct. 13. Which of the following is a solution? Air, water, and
Sir,
air.
I think all the questions are repeating because the 11th and the 12th question was the same, and the 13th question is also the same.
Okay. It also the file get corrupted, I think so. Okay, nonetheless, we have finished some of the question number 13, 14th. This file got corrupted while uploading in Canva. We will be continuing the MCQ in the next class. So let's move on to core concept of today's class, which will be about the force and motion like that. Do you want to ask anything in the yesterday's class like polarity, water molecule, electronic configuration, etc.? Should I revise it?
No, sir.
Okay, so let's move on to the next one. So the question, the chapter is the new chapter we are going to study is about the force. We will be discussing its formula, example, push and pull, mass, velocity, speed, acceleration, effect of the force and masses. Then we are going to understand direction, speed, what is a direction, state of an object, whether it is in rest or motion, change in shape, and some kind of the other forces as well. So let's begin with a question. What is a force? And what do you think? What is a force? Or we can say that where you apply the force in your real or everyday life. You can give some of the example where you apply force.
Sin, sin, so when we apply a push or pull on some object or on a living thing, it's called an force. Basically, suppose when we are uh, pushing a box to keep it to somewhere else, that time we apply the force on the box. And suppose we are kicking a football, or like in the presentation, a man is swinging her daughter or whatever. So that's the example in real life.
Yeah, great. So we know by experience the force in our because of use in our day-to-day life. But when someone someone says what is force, explain to me mathematically. So it can be a little bit challenging. So we have to give a scientific definition. A force is, a kind of a push or whether a pull. So we can define a force is a physical quantity that when applied to a body can change or tend to change the state of rest or uniform motion of an object and can change its shape. So now if we consider this example, so this brother is pushing his little sister when applied to a body. So her sister we can consider a body can change or tend to change. If he applies, his position can change. If it is at the uniform speed, meaning it was at the rest, so it can set that his sister into the motion, or if it is already in motion, so he can either increase or decrease that motion. So that is the basic definition of the force. Mathematically, we can also say force is equal to mass into acceleration. But forget this thing, mass into acceleration. Let's understand some of the key concept of the class. Some of the key concept or the terminology used in the physics. What is a mass? But prior to that, my question is, what is your favorite dish?
So challenging, but I like all the junk foods.
Many of the
Like
things. Can you
I cannot select one, but basically I most of the time I like pizza.
pizza you like? Or you can also list name some of other things you usually like to eat.
Momos,
Momos you
um,
like.
noodles, and many more.
Okay, many more things. Great. So I think we have a common favorite dish list. But nonetheless, so what is pizza or momos is made up of? We know that every material is made up of atom or atoms and its subatomic particles, or we can say the constituent particle. Suppose momo is made up of flour. The small particle of flour we can say is a constituent particle of the entire momo. For the sake of to make it easy, let's take an example of water. Now, water is made up of what?
Hydrogen and oxygen.
Yes, exactly. Water is made up of hydrogen and oxygen, or we can say water is made up of H2O. So we can consider H2O as a constituent molecule for the entire water. So H2O is the constituent molecule for the entire water. Now, what is a mass actually? So mass is the number or the amount of constituent particle present inside the matter. So for any matter of which it is made up of, the mass is the measurement of the number or amount of the constituent particle present inside that particular substance. We take example of the water. So we can say what is the mass of water? So we can say the amount of H2O molecules present inside the water is nothing but its mass, right?
Yes, sir.
Now these two terms are sometimes confusing, like what is weight or mass. So weight is a gravitational force. We know what is a gravitational force? Gravitational force exerted by a planet. So gravitational force works on the two bodies. If there is one body, suppose this is Earth and this is, let's say, any person, random person, another body. So Earth exert a force on this particular body. So we call it a gravitational force or gravitational pull. So weight is the measurement of that force. So weight is the gravitational force exerted by a planet such as Earth on a body of mass. Let's take an example of M. It is a force by which the body is attracted towards the center of planet. So this particular gentleman can be attracted by, is being attracted by the earth. So this is a weight, while the mass is the number of constant particle present inside this body. So we can take an example of a human being, and we know what is human being made up of. The building block of the human being, what is it?
The cell.
Cell. So we can say, if somebody say what is the mass of a human body, we can say the number or the amount of the cell present inside the body, right? While weight is the amount, the magnitude of the force, especially the gravitational force exerted by one body, especially the earth, onto the other body. So weight mathematically is mass into gravitational. So these are the two terms we have understood, mass and weight. Now let's look a closer look, glimpse onto these particular two things. So mass is the amount of matter present in the body or amount of the constituent particle by which it is made up of present in the body. Gravitational, while weight is the gravitational force acting upon that particular mass. So there is no formula for the mass, but there is formula for the weight, which is m, mass of the body, times gravitational force. Regarding its quantity, they are scalar and vector quantity. Basically, scalar quantity are those with the directionless, those who don't have any direction. The opposite is the vector quantity, meaning they have direction. Depends upon, mass will depends upon what? The number of particle inside that body, while weight will depend upon the mass as well as gravitational force. So regarding the changes in the location, so moon has the mass equivalent to 1/6 of the earth. So it is 1/6 time lesser than the earth. So one person from the earth goes into moon, he will feel lesser weight, lesser weight at that particular by that particular moon by 1/6. His weight will be reduced by 1/6. And why? Because the moon has 1/6 time lesser weight as compared to the earth. So there was a movie, Hollywood movie named John Carter. So the story is like John Carter went from earth to moon by something, some miraculous thing, and then he is jumping too long in that Mars. So he went into Mars and he's jumping too long. Suppose he went to into the moon and he was jumping too long, and he was confused why he's able to jump so high, and that's because the mass of the moon is 1/6 lesser than that of the earth. So this is the difference between mass and weight. So we have understood what is a mass. Now there is a question, what actually we measure. So when we go to the weigh machine, we put ourselves into the weigh machine. So the answer is we measure weight, but the weigh machine says you are in kg, while kg is the unit of mass and Newton is the unit of weight. Want to ask anything?
No, sir. I was just a little bit shocked that the weighing machine shows it the weight in kg while it should be in newtons.
Yeah,
So
exactly.
it can be that the newtons are converted into kg.
Yes, exactly. Newton is converted into kg, and then that's why we got it in kg. But it is surprising that the weigh machine measures our weight into Newton, because it is measuring our weight, not our mass, right? So the weigh machine measures our weight. A weighing machine measures the force you apply on it due to the gravity. Inside the machine, sensor detect this force, that is in Newton, and it convert into the gravitation kg by dividing it by 9.8 meter per second, which is the standard value of the gravitational force, that is g. So it basically divides, or we can say eliminate the g from the measurement, and it gives into the kg. Now here is a question: which one is easy? So you have to figure it out. So we have to kick 5 kg ball, or we have to kick a 10 kg ball. Which of these ball would you think is easy to kick, and why?
So I think the 5 kg ball will be easier to kick as it is lighter in mass.
Yeah, exactly.
Mass, not in weight actually. It's lighter in mass. It has less mass inside it. But when we keep it on the surface, it exerts force on the surface and the mass converts into the weight because it
Okay,
exerts force on the like on the earth, we can say.
exactly. So when we are kicking the object, that is the football, so we are basically applying a force against the gravitational force, isn't it?
Yes,
So a
sir.
force already has been, by default, has been applied to that particular ball by the gravity when we are moving it. So we are just basically working against the gravitational force, or we are breaking the force which has been applied by the gravity. So you say that 10 kg ball is easier to kick. Sorry, 5 kg
No,
ball
sir.
is, okay, sorry. 5 kg ball is easier to kick because it has lesser mass. And now the question is, because we are applying force to the ball, my question is, do mass has anything to do with the force? No, yes, it has. So you answered it right. You say 5 kg ball is easier to kick. When we are kicking, we are applying a force. So
Hmm.
5 kg mass is easier to kick, and while 10 kg mass is heavier, we can say, to kick. So mass has direct relation with the force. More force we apply, it can push the heavy object, and when it comes to the kicking a lesser uh, lighter object, we apply little force, isn't it?
Yes, sir.
So we can think that, we can say that mass has a direct relation with the force. Now we understand what is a force, at least in terms of the mass. We know mass is equal to force. We apply greater force, greater mass body will be kicked up, and we apply little force, a lighter body will be kicked. So we know now what is force in terms of mass, and we can say it has a direct relation with the object. Simply I call it brother sister relation. Now we know force is equal to mass. Now let's understand what is acceleration. So when it comes to the inverse relation, we will be studying in some time. Inverse relation meaning we apply the force become lesser, and we, if the mass is in the inverse relation, so it would be that greater the mass, lesser the force, and greater the force, lesser the mass. I call generally this is a uncle son relation. Okay, so now let's understand what is acceleration. For that we need to understand what is a displacement. So suppose this is your house, and this is your current location, and this is the place you wish to go. So naturally, you will go the shortest distance possible, right? In order to save the time and your energy as well. So you choose 5 meter distance. If anything happens in this particular place, like the heavy traffic, etc., so you can choose the alternative path. You can go to your home traveling by 4 kilometer and then 3 kilometer to that particular place. When it comes to measuring a displacement, so displacement is the shortest length possible between two objects. Displacement is the shortest straight line distance between the initial position where you were at A and the final position C where you wish to go. It is a vector quantity, has a direction. We will be discussing this on later. Depends only initial and final position. Displacement do not depends on the path we traveled. And it can be zero if the distance is zero. I am going to explain this particular thing in the next slide. So it depends only on the initial and final position. Suppose you travel from A to B 4 kilometer, then B to C 3 kilometer, total 7 kilometer. If at the place C, I calculate what is your displacement, then I will calculate the 5 meter will be your displacement, as the displacement is the shortest distance possible, while your distance will be 4 kilometer and 3 kilometer. Now I hope you understand the difference between displacement and displacement and the distance. Now let's understand velocity. Is everything clear up to now?
Yes, sir.